Download this code from codegive.com, link in the description below. Suppressing insecure request warning in Python, a detailed guide. When working with Python and making HTTP requests to HTTPS endpoints that have issues with SSL certificate validation, like self-signed certificates or expired certificates, you might encounter an insecure request warning. This warning, raised by the urlib3 library, which requests uses under the hood, alerts you to the potential security risks associated with connecting to a server without proper SSL verification. While you might temporarily want to suppress this warning for development or testing purposes, or in situations where you understand and accept the risks, it's crucial to understand why the warning exists and to ideally address the underlying SSL issue whenever possible. Blindly suppressing warnings without understanding the consequences can leave your application vulnerable to man-in-the-middle attacks. This tutorial will cover 1. Understanding the insecure request warning *, what it means and why it's important. 2. When it's not a good idea to suppress the warning. 3. Methods for suppressing the insecure request warning *. Using warnings. Filter warnings. Disabling verification directly in requests. Using urlib3 directly to disable warnings. 4. Addressing the underlying SSL issue, the preferred solution. Installing a proper SSL certificate on the server. Trusting the server's self-signed certificate. 5. Code examples illustrating each method. 6. Best practices and security considerations. 1. Understanding the insecure request warning. The insecure request warning is raised by urlib3, the underlying HTTP library used by requests, when it detects that SSL certificate verification has been disabled. SSL certificate verification is a critical part of HTTPS. Here's a breakdown. *HTTPS, HTTP Secure uses SSL/TLS to encrypt communication between your application and the web server. This protects data in transit from eavesdropping and tampering. *SSL/TLS certificate *, a digital certificate that verifies the identity of the web server. It contains information about the server's domain name and is signed by a certificate authority, CA. Certificate authority, CA, a trusted third-party organization that issues and manages SSL certificates. Browsers and operating systems have a built-in list of trusted CA. *SSL verification *, the process of checking whether the server's certificate is valid and trustworthy. This involves checking that the certificate is signed by a trusted CA. Checking that the certificate's validity period, expiration date, is still valid. Checking that the certificate's domain name matches the domain you're trying to connect to. Insecure request warning trigger *, when you disable SSL verification, you're bypassing these security checks. The insecure request warning is a reminder that you're potentially exposed to risks. 2. When it's not a good idea to suppress the warning. Suppressing the insecure request warning should generally be avoided in production environments or when dealing with sensitive data. It's particularly dangerous in the following scenarios. Accessing production servers or services. If your application interacts with production APIs or databases, you should always verify SSL certificates. Transmitting sensitive data. Anytime you're sending or receiving passwords, financial information, personal data, or other confidential information, SSL verification is essential. Publicly accessible applications. If your application is used by others, you have a responsibility to ensure their security. In these cases, fixing the underlying SSL issue is the correct solution, not suppressing the warning. 3. Methods for suppressing the insecure request warning. If you understand the risks and still need to suppress the warning, Example for testing against a local development server with a self-signed certificate. Here are several methods. 3.1. Using warnings. Filter warnings. This is the most common and recommended way to suppress warnings in Python. It allows you to selectively filter out specific warnings. Explanation asterisk. Asterisk import warnings, imports the warnings module. Asterisk warnings. Filter warnings, ignore, category equals erlib3.exceptions. InsecureRequestWarning. This line tells Python to ignore warnings that match the following criteria. Asterisk ignore, specifies that the matching warnings should be ignored, not displayed. Asterisk category equals erlib3.exceptions. InsecureRequestWarning, specifies that the warning must be of the type InsecureRequestWarning and originate from the erlib3.exceptions module. This ensures that you're only suppressing the specific warning you intend to suppress. Asterisk requests.get, URL, verify equals false. This is crucial. You still need to explicitly disable SSL verification in the requests library using verify equals false. The warnings. Filter warnings, only prevents the warning from being displayed, it doesn't disable SSL verification itself. If you omit verify equals false, requests will still attempt to verify the certificate and raise a requests.exceptions.ssl error. 3.2. Disabling verification directly in requests, using verify equals false. This is the most straightforward, but least recommended way to suppress the warning and disable verification. It's generally better to use warnings. Filter warnings, in conjunction with verify equals false because it makes your intention clearer and allows you to be more selective about which warnings you suppress. Explanation asterisk. Asterisk requests.get, URL, verify equals false, disables SSL verification for the specific request. Asterisk requests.packages.erlib3.disable_warnings, this line globally disables all erlib3 warnings. It's important to note that this affects all subsequent requests made using requests within the same process. This can have unintended consequences if you're making requests to other, secure endpoints later in your code. This method is generally discouraged because it is very broad. 3.3. Using erlib3 directly to disable warnings. If you're using erlib3 directly, which is less common than using requests, you can disable warnings like this. Explanation asterisk. Asterisk erlib3.disable_warnings, disables all warnings from the erlib3 library. This is a global setting and affects all subsequent erlib3 requests in the same process. Like the requests method above, this is discouraged for its broad scope. 4. Addressing the underlying SSL issue, the preferred solution. The best solution is always to address the underlying SSL issue. This involves either installing a valid SSL certificate on the server or, if you're in a controlled environment, like a local development server, telling your client, your Python application, to trust the server's self-signed certificate. 4.1. Installing a proper SSL certificate on the server. This is the ideal solution for production environments. It involves obtaining a valid SSL certificate from a trusted certificate authority, CA, and installing it on your web server. The process varies depending on your web server, example Apache, Nginx, IIS, but generally involves 1. Generating a certificate signing request, CSR. This creates a file containing information about your server and domain name. 2. Submitting the CSR to a CA *. You'll typically pay a fee to the CA for issuing the certificate. 3. Installing the certificate on your server *. The CA will provide you with the certificate files, which you'll then install on your web server. For configuring your web server to use the certificate * you need to configure your web server to use the newly installed certificate for HTTPS connections. Once you have a valid SSL certificate, clients connecting to your server will automatically trust it, and the insecure request warning will no longer be raised. 4.2. Trusting the server's self-signed certificate, for development/testing. If you're working with a self-signed certificate, common in development environments, you can tell requests to trust that specific certificate. This is better than completely disabling SSL verification because it only trusts the certificate you specify, rather than disabling verification entirely. Method 1. Specifying the certificate path. Explanation ***certificate _path specifies the path to the PEM-encoded certificate file. This file contains the server's public key and other information about the certificate. You need to obtain this file from the server administrator, or generate it yourself if you created the self-signed certificate. *verify equals certificate _path tells requests to verify the SSL certificate against the certificate at the specified path. Requests will now trust the certificate specified and no insecure request warning or SSL error will be raised if the connection succeeds. *error handling, wrapping the requests.get, call in a try, except block allows you to gracefully handle requests.exceptions.ssl error exceptions that might occur if the certificate is invalid or if there are other SSL related issues. Method 2. Using Certify and appending to its trust store, advanced. The Certify package provides a curated collection of trusted root certificates that requests and other libraries use for SSL verification. While modifying Certify directly isn't generally recommended, it can be useful in certain scenarios, especially when dealing with internal CA in a corporate environment. Use this method with caution as it affects all libraries using Certify. Important considerations when using Certify ***. Security implications * modifying the Certify trust store can have security implications. Be absolutely sure you trust the certificate you're adding. Updates * when Certify is updated, your modifications might be overwritten. You'll need to reapply the changes after each update. Environment variables * consider using environment variables to specify the certificate path instead of hard-coding it in your script. This makes your code more portable and configurable. 5. Code examples summarized. Here's a combined set of code examples covering all the methods discussed above. Remember to replace placeholder URLs and certificate paths with your actual values. 6. Best practices and security considerations. Prioritize fixing the underlying SSL issue. Always try to resolve the SSL certificate problem first. Avoid disabling verification in production. Never disable SSL verification in production environments. Use warnings. Filter warnings selectively. If you must suppress the warning, use warnings. Filter warnings to suppress only the specific insecure request warning. Never globally disable warnings. Avoid requests.packages.erlib3.disable_warnings or erlib3.disable_warnings as they affect all requests in your application. Handle SSL errors gracefully. Use try, except blocks to catch requests.exceptions.ssl error exceptions and handle them appropriately, example logging the error, displaying a user-friendly message. Regularly review your security practices. Keep your SSL/TLS certificates up to date and regularly review your security configuration. Consider using a more secure method for trusting self-signed certificates. Instead of directly modifying the Certify bundle, explore creating a custom CA and signing your self-signed certificates with it. This provides a more robust and manageable way to manage trust. By following these guidelines, you can minimize the risks associated with disabling SSL verification and ensure that your Python applications are as secure as possible. Remember that security is a process, not a one-time fix. Stay vigilant and keep your systems up to date.